Today we're going to continue talking about three-dimensional vectors. Just like we had with two-dimensional vectors, you can find your components from your initial and terminal points. The only difference is now you're going to have three components instead of two. You also can find your magnitude. It's the same thing, just like you did x squared plus y squared in your components. It's x squared plus y squared plus z squared. And again, to find a unit vector, you simply find the vector divided by its magnitude. Okay, so nothing is different with three-dimensional instead of two-dimensional vectors. So it says find the component form and magnitude of AB with initial points A being -4, -2, 1, and terminal point being B, 3, 6, -6. Then find the unit vector and direction. So what I'm going to do first is I'm going to find vector AB. And how I do that, remember, is I just subtracted. I took 3 minus a -4. I took 6 minus a -2. And I took -6 minus 1. Remember, always starting with my initial point, with my terminal minus the initial point. So 3 minus -4 is 7. 6 minus -2 is 8. And -6 minus 1 is -7. So here is vector AB right here. Okay? There it is right there. Now the next thing it said to do is to find its magnitude. So remember how we find magnitude is the magnitude of AB, square root of 7 squared plus 8 squared plus -7 squared. Okay, I put that into my calculator. 7 squared is 49, 8 squared is 64, and -7 squared is 49 again. Square root of that ends up being approximately 12.7. So my magnitude is 12.7. Finally, the last thing I need to find is the unit vector. And so remember, finding unit vector, what we did is we took our components of AB divided by the magnitude of AB. So that would be 7, 8, -7, all divided by 12.7. And what I end up getting is 7 over 12.7, 8 over 12.7, and -7 over 12.7. Just as an easy way to do it. We could simplify farther, but let's just make it easy on ourselves and say that's what it is. So, magnitude, unit vector. Here's a couple guided practice if you want to try these. Start with the terminal point minus the initial point to find your components. Find the magnitude, then unit vector. Alright, so vector operations are just like we had before. The only difference is now, again, you have that third point. So when you add your two vectors, you add A1 plus B1, A2 plus B2, A3 plus B3. Subtraction, same thing. Subtracting the two. And then scalar multiplication, you just take your value and multiply it by all your components. So if I was going to look at example 5, it says find each of the following for y is the vector 3, -6, 2, w, -1, 4, -4, and z is -2, 0, 5. So if I'm going to find 4y, okay, 4y is just 4 times the components of 3, -6, 2, which would be the components 12, -6, 12, -24, 8. And then we want to find what 2y is, or 2z is. And so that's going to be -2, 0, 5. So -4, 0, 10. And so what I'm going to do then is I'm going to add those components together. Right? Okay, so 12 plus -4 is 8. -24 plus 0 is -24. 8 plus 10 is 18. So that's what 4y plus 2z is equal to. Now in letter B we have 2w. So 2 times w, which is -1, 4, -4. So that ends up being -2, 8, -8. Then we have minus z, so z is going to remain the same. And so z is negative 2, 0, 5. And then finally we have 3y. And so that's going to be equal to 3 times 3, negative 6, 2. So 3 times 3 is 9. 3 times negative 6 is negative 18. And 3 times 2 is 6. So my job now is to take this number, 2, negative 2, minus this number, and then add this number. So negative 2 minus a negative 2 is 0, plus 9 is 9. Then we have 8 minus 0 is 8, plus negative 18 is negative 10. And then finally, negative 8 minus 5 is negative 13, plus 6 is negative 7. So there are my components. Here's 2 guided practice problems. Feel free to try those now. So finally, we put all of this together so that we can put this applied to a word problem. So it says, after liftoff, a model rocket is headed due north and climbing at an angle of 75 degrees relative to the horizon at 200 miles per hour. If the wind blows from the northwest at 5 miles per hour, find a vector for the resultant velocity of the rocket relative to the point of liftoff. So, if we're looking at our three-dimensional plane, okay, east and west runs towards us, that's the x-axis. We'll make north and south run as the y-axis, and then there's not going to be a negative, but a positive z would be our up. So our rocket starts right here at our origin, and it says that it's headed due north and climbing at an angle of 75 degrees relative to the horizon. So what we end up getting is this vector right here. You'll see that it forms a 75-degree angle. So what we need to do is we need to find its resultant vector. So in our x-axis, our rocket doesn't move at all. So it has a point 0. It does not move east or west at all, heading due north from the horizon. So to figure out our next components, we take our magnitude of 200 times the cosine of the 75 degrees in which it's headed. We also take 200 sine of 75 to find its component vector in the up position on the z-axis. So I put all this into my calculator, and so my vector is 0, 51.8, 193.2. So it makes sense that the rocket is moving essentially 193 miles per hour in the up position and 51 miles per hour in the north direction because it's headed due north. Now the next thing we have to take into account is our wind, and it says it's moving from the northwest and going this way. Now to figure out an angle for it, we have the magnitude of 5, that we already know, but to figure out our angle, it might be a little bit odd for you to think about. We have to start from the positive x-axis, which would be right here at east. And so I go 90, and then another 90 over to west, plus another 90, which would be 270, plus the 45. So it ends up being 315 degrees, and you can see it drawn right here, which is not in your notes. So to figure out then our next vector, it's going to be the component. Okay, well first off on the x-axis, that's going to be 5 cosine of 315 degrees. Then on the y-axis, it's going to be 5 sine of 315 degrees. And in this one, there is no up component, so it's going to just be 0 for the z-axis. Okay, so you put this into your calculator, you end up getting, this would be a positive 3.5, 5 sine of negative 315 is a negative 3.5, and that's 0. So now we need to find the resultant vector. So I'm going to take my original vector for the rocket launching, the vector for the wind, and I'm going to simply add them. So my resultant vector 0 plus 3.5 is 3.5. 51.8 plus a negative 3.5 is 48.3. And 193.2 plus 0 is 193.2. So this right here is the full direction and speed at which our rocket is going.